Okay, we've talked about area in our last set of lessons, and we learned how area was a measure of the number of squares that it takes to cover a two-dimensional object. Okay, so I kind of got rid of all of the other parts of the definition, and I'm just looking at the really important words. Area is a measure of number of squares. We are using the squares to cover a two-dimensional object. In this lesson, what we're going to be talking about is the next step. We're going to be moving up to three-dimensional objects, and we're going to be talking about the concepts of volume and surface area. And so we're just going to jump right into it and talk about what volume is. We're going to talk about what surface area is, and we're going to learn how we can evaluate or calculate those things. So let's get right into definitions. Volume is a measure of the number of cubes of a given size required to fill a three-dimensional object. When we measure volume, we're not covering something, we're not surrounding something like we do with perimeter, we are filling something. And you can't fill something with squares because squares only have two dimensions, but we can fill things with cubes. So if we've got a three-dimensional object and we're trying to fill it, that's a volume problem. Surface area is kind of very similar to regular area. Surface area is the measure of the number of squares of a given size, just like regular area, required to cover something. But now what we're doing is we're not just covering a two-dimensional object, we're covering the surface of a three-dimensional object. So if you can think of any three-dimensional object you want, a table, a basketball, anything that you want, a human being is a three-dimensional object, and you can think, how many squares would it take to cover all of the outside surfaces of that object? That's the surface area. Okay, let's spend a little bit of time talking about the definition of volume in particular, just because we kind of already know what area is, surface area, because we've already talked about area. Let's talk about volume. And what I'd like to do is talk about this idea of filling things with cubes. I went to Google SketchUp and I drew some cubes. So if you take a look at this, what you see here drawn to scale is a 1 foot by 1 foot by 1 foot cube. It's a box. And I cut off one side so we could look right inside that box. This box that's 1 foot by 1 foot by 1 foot then has a volume of 1 cubic foot. And that's how we write a cubic foot. 1 foot. And then notice we have the exponent to the third power. Just like when we did area, we did an exponent to the second power. Now we've got our exponent to the third power. Okay? Now inside of here you see some smaller cubes. And I put those smaller cubes in there to scale so you could get an idea of the relationships that are going on. If you look at those smaller cubes, what you're looking at in particular, I wish I could get rid of this. This is not helping me at all. Come on. All right. You don't like me? Fine. Be that way. Okay. You take a look inside of the big box, you're going to see these little boxes. And the first little box that you see is 1 inch by 1 inch by 1 inch. That means this box right here has a volume of 1 cubic inch. Now inside that there's an even smaller box. Turns out that that box has dimensions 1 centimeter by 1 centimeter by 1 centimeter. So the volume of that box is 1 centimeter cubed. So if you take a look at all of these boxes again together on the same page, you get a little bit of a relationship in terms of the size about how big those things are. Now you don't get the picture of the real size of the box by looking obviously at this video, but if you were to look at the squares on the floor of our classroom, Those squares are 1 foot by 1 foot squares. Now imagine each of those squares going up in the air 1 foot. That's how big a cubic foot is. And then inside of there, you can put in cubic inches and cubic centimeters. All right, so it's important that we talk about the size of the cubes when we talk about volume, just like we did when we talked about the size of the squares when we talked about area. Very, very important. Okay. Now, one of the things that we want to think about is how many cubes of a certain size can fit into bigger cubes. So I've blown this back out again, and we're looking at our cubic foot. I really wish I could get rid of this. Let's try this. Hey, there we go. Okay, we're looking at our cubic foot, and inside of there we've got our cubic inch and our cubic centimeter. Now think about this. If I went all the way along the back of this thing right here, went all the way along the back, it would take me 12 cubic inches going across the back and 12 more going this way to fill up the entire bottom layer of this box. And then I would have to stack those inches 12 high in order to completely fill in the cubic foot. So what am I saying is that 1 cubic foot is the same thing as 12 inches by 12 inches by 12 inches. So if I want to see how many cubic inches are there in a cubic foot, I'd have to multiply 12 by 12 by 12 to get that answer. All right, there's a lot of cubic inches in a cubic foot. Remember, we talked about this with square feet. Remember how in a square foot there were 144 square inches, not 12? Same thing with a cubic foot. With a cubic foot, there's not 12 cubic inches in it, and there's not 144 cubic inches in it. Turns out there's 12 by 12 by 12, which is 1,728 cubic inches. And if you look inside of there, you can see that there's even a lot more cubic centimeters because that cubic centimeter is really, really small compared to that cubic foot. Okay? And so what that leads us to is some important conversion factors that we probably should be aware of to make sure that we understand kind of the relationship between the sizes of these various things. We didn't talk about, or I didn't show you a picture of a cubic yard, but if you look at a cubic yard would have dimensions that would be 3 feet by 3 feet by 3 feet. And the cubic yard is something that shows up in construction a lot for you manufacturing people. And as it turns out, if you multiply 3 times 3 times 3, you get a total of 27 cubic feet. So this is an important conversion factor. A cubic yard has 27 cubic feet in it. So if I go back like this, that's a cubic foot. Okay, it takes 27 of those to fill a cubic yard. It takes 1,728 cubic inches to fill 1 cubic foot. And it takes a little more than 16 cubic centimeters to fill in 1 cubic inch. So if I go back a couple right here, here's my cubic centimeter, all right? It's going to take me about 16 of those to fill up this cubic inch. And then it takes 1,728 of those cubic inches to fill up a cubic foot. And it takes 27 of those cubic feet to fill up a cubic yard. Hopefully you kind of get the picture of how that works. So these are important conversions. I would think these are conversions that would probably end up somewhere in your measurement handbook along the way because these things come up along the way and we have to be able to deal with that. Now, let's get down to actually calculating volume. When we calculate volume, just like when we calculated area, usually we don't go around plugging cubes into something to see how many fit. We have formulas that we work with. And there's really a handful of very common formulas that you need to be able to work with when we talk about volume. So we're going to go through and just talk about the formulas for each of these things right now. The most common shape is your basic box, which is called a rectangular solid. And a box has a length, it has a width, and it has a height. And if you want to find the volume of a box, all you have to do is multiply the length times the width times the height, and you're going to have your answer. Now, If we want to find the surface area of a box, which would be how many squares does it take to cover the surface of a box, okay? There's a formula for that as well, and I'm going to use S to stand for surface area. It's a little bit more complicated formula because really what we have to do is we have to find the area of all the rectangles that make up the surface of the box. So the formula, as it turns out, for the surface area of a box looks something like this. 2 times length times width plus 2 times width times height plus 2 times length times height. What that formula does is it figures out the total number of squares, you know, the L times the W, this piece of the formula right here. If I find the L times the W, that's going to tell me how many squares are on the top of the box and how many squares are on the bottom of the box. The W and the H are going to tell me the right side of the box and the left side of the box. And the L's and the H's are going to tell me the front of the box and the back of the box. Okay, so now that I've made a big mess of this whole thing, let's erase it all again and go through and let me relabel my sides. So I've got my length right here, my width right here, and my height right here. And if you know those three measurements, you can figure out the volume and the surface area of your rectangular solid. Let's go to our cylinder. Our cylinder looks like a can. And a cylinder has really two important measurements that you need to know. Just like a circle, it has a radius, but a cylinder also has a height to it. And if you know the radius and the height, you can figure out the surface area and the volume of a cylinder. The volume can be found by taking pi times the radius squared times the height. That's the formula that'll tell you how many squares fit inside the cylinder. I'm sorry, how many cubes fit inside the cylinder. If you want to know how many squares it takes to cover the cylinder, you use the formula 2 pi r squared plus 2 pi rh. As it turns out, the 2 pi r squared tells you the area of the top and the bottom of the cylinder, and the 2 pi rh tells you the area of the sides of the cylinder. All right, let's move on to our cone. Our cone has three important measurements that you need to know. It's got a radius, it's got a height that goes right from the tip of the cone straight down to the middle of the circle, and then it's got another dimension, the length of the slanted part of the cone, which is called the slant height. And if you know those three things, you can figure out your volume and your surface area. The volume of a cone is 1/3 pi times radius squared times height. It's almost the same thing as the volume of a cylinder, but you got to multiply by 1/3 because you got a bunch of extra pieces chopped off. The surface area, as it turns out, is equal to pi r squared. That's just the bottom part of the cone, the circle, plus pi rl, which is going to tell you this area of the sides of the cone. Okay? And that leaves us with one more basic shape, and that's the sphere, like a ball. A sphere only has one dimension that you need to know, and that dimension is the radius. The volume of a sphere can be found by taking 4/3 times pi times the radius raised to the third power. That'll tell you how many cubes fit inside of a sphere. The surface area can be found by taking 4 times pi times radius squared. That'll tell you how many squares it takes to cover the sphere. And that's all you really need to know about a sphere. So these are the formulas that you really need to know. And what we're going to do is, just like we did with our area formulas, we're going to practice using these things. I'm going to show you one example to give you an idea of what you need to be able to do, and then hopefully you'll have enough that you can just start working on the assignment that goes along with this lesson. So here's the problem that we need to do. We need to find the volume and the surface area of this cylinder. This is what I want you to do. I need you to be able to start out by writing the formula that you're going to use. So volume is equal to pi r squared times h. That's what you want to do, is write your formula down to get started. And then after you write the formula down, substitute your numbers in. So the radius is 7, so I'm going to put a 7 here. And the height is 12. So I'm going to put a 12 right here. Now, the rest of the problem, you can just use your calculator, and you can do pi, which I'll use 3.14, times radius, because it's radius squared, times the height. When I multiply that all together, I get an answer of 1,846.32. Let's try to copy it, if it'll let me. And then we'll go over here and we'll paste it. That way I don't have to remember it. And here's my answer. But it's really, really important that you tack on the units. We just found that it's going to take us a total of 1,846 cubes that are 1 inch by 1 inch by 1 inch to fill in that cylinder. 1,846.32 cubic inches is the volume. Now the surface area, same thing. All I have to do is write down my formula. 2 pi r squared plus 2 pi rh. Okay, just coming from this formula back here. See, there it is. That's it, just writing it down. And then all I got to do is plug the values in. Okay, so if I go back here and I plug in my values, let's see what I get. I have 2 pi times 7 squared plus 2 pi times 7 times 12. Now, I'm going to do a little extra work on here just because the formula is more complicated, so I'm going to do 2 times pi times 7 times 7 equals 307.72. 307.72. And then I'm going to go do this other part over here separately. So I'm going to do 2 times pi times 7 times 12. And I'm going to get 527.52. And then I can add those two things together. And you wouldn't necessarily have to do two separate pieces. You could do it all at once if you wanted to. And I'm going to get 830.24, I think. I better add it up right, just to make sure. 307.72. 835.24. Let's try it. Right, that over again. There you go. And what did we just find? We found the number of squares it takes to cover the outside of the object. Okay, that's what surface area is, the number of squares it takes to cover the outside surfaces of the object. Now, that's the basics. What it comes down to is make sure you know what volume is, make sure you know what surface area is, and make sure you can use these formulas to figure that out. Now it's just time to practice.